Okay, so I decided to keep the modding train going and go ahead and do a part 2 and maybe a series. So one of the things I've done already is I added this very useful 2D graphics library, mainly for the roto zoom function, as well as anything else I might need. Then I slopped up some game assets, namely the rifle here. So instead of seeing that ugly yellow line, it's now starting to look like a real game. And you see you can freely aim and rotate, and that's all done by the very handy roto zoom here. Another thing I did is refine the vehicle entering and exiting system, as well as movement. So now anytime you're near a vehicle, you can press E and fly around up and down with acceleration, with all the correct collisions and boundaries. And you can exit the helicopter anytime you want, as so, and it will just fall to the ground. You can go back. And if we ever run into any problems, we have this mofo right here. Basically concluding the whole arbitrary vehicle system. So, fuck. That being said, the firearm mechanism is still the same, and this is where we encounter our first major roadblock. So everything, the characters as well as the vehicles are an entity, which the engine handles all the collision, gravity, platforming and all that. But the problem is we want to be able to fire bullets at an angle and have them register a hit either really quickly or immediately. And using an entity for a bullet isn't going to work, because if we make the bullet velocity really high, it's just going to run through the enemies, right through them. So then we have to do some additional linear interpolation. And if we keep it slow, it's not really going to feel like a proper firearm. So we'll begin by attempting to address this and see how far we get. So the first problem is that this vector does not interact with any of the tiles, trajectory vector that is. So it interacts with the entities obviously, but not with the tiles. So we'll begin by taking a peek by exposing our X and Y location, player location, as well as the tile location and the tile value at said location. So now, as you can see, I can walk around and know where everything is, and I know that all the tiles. So this was tile 2 and this was tile 14, I guess. I guess I put the map at the very end now. And it looks about right. So, following the theme of procedurally generated map, one of the things I can do is I can play the game, walk around, and when I feel like I need to add something, I just do it immediately. So, say I want to add like 3 tiles right here, I'm gonna do that. So, this is 1 tile, this is the next tile, it's gonna be 44 and 12, 44 and 11. So 44 and 12. We'll go like this. Put a tile there. So column 44, row 12, layer 1, and let's use tile 2. And we see immediately we get a nice tile there. We can just move it one over for fun and add 3 more. So, and here we note our first problem is that we can shoot through the tile. Now let's make these even closer. Hopefully I can jump over this. So if I shoot the enemies with line of sight, they drop as expected. But if I shoot the enemies through a tile, they also drop. And what I'm gonna do is increase the weapon range to about let's go 200. So now you see that I'm able to shoot all the enemies through the wall. And that's the first thing we'll have to fix. And to do that, we just have to terminate this red trajectory vector at the tile. So let's attempt this. Since this happens in the drawing section, we will begin there. So make this 200, and that's our weapon range, total range now. And on top of checking for enemy collisions, we are also going to check for tile collisions first. So let's take these two tile transformations. We'll call this tile coordinates. This is going to be one thing I want to see is if I can move the drawing stuff to the logic. this. See if I can comment it out and see something. Unfortunately not. So I'm going to copy this scheme into our drawing logic. And I'll comment out this section for now. Here is our, delete this. Put this here. Make it red. And we can even comment this part out for now. GX. And yeah, just getting warmed up. Okay. So now we're tracing the trajectory, and we're doing it probably close to pixel by pixel, but if we're to make it a little wider, or whatever. So now, given that we know these coordinates, all we have to do is check if it collides with any of the tiles. And to do that, we know this happens. So that and then here, so this should vanish. And then I just, when I draw it, I account for the scene. But when I'm doing logic, I'm accounting for the absolute coordinates. It's going to be a running theme of confusing scene coordinates and running coordinates, but one of the things we'll have to keep track of. So then, let's then also print the final absolute coordinates. So that will happen once this loop terminates. X, Y. Make them integers. It's another thing to remember that these have to be integers. So since we know our weapon range is 200 and we're standing at, say, 700, that means that if we're aiming straight across, yeah, we get 900 as expected. Straight up, we get nothing. Yeah, interesting. So then, what we can do is, if our coordinates happen to hit a tile, let's see this. If tile is not 0, then exit 4. Yeah, it's getting quite messy with the prints, but that's how it is. And this should be T. Okay, just basic errors, really. Typos. And there we have it. So when it's intersected with a tile, the trajectory vector terminates, disallowing us to shoot through walls. And surprisingly, that's already working. Huh. Nice. That's surprisingly easy, okay. So we delete the decorations. So let me just disable this logic for now, the hit logic, player hit, and just see what we have created. So now let's check for player collisions. Is that right? Okay, we didn't need to uncomment that. Rather this. Or I'm just gonna redo this for I. First we check for player collisions. Let's say EX equals GX. do this, and then anytime there's such a collision, we are going to draw a green circle. Or yellow. Let's make it green just so we're sure of ourselves. Yeah, there we go. So now I'm not able to shoot through tiles. I'm able to see when the bullet collides with any enemy, and I can't shoot through walls. So the next part is converting all this drawing logic into hit logic. Otherwise, yeah, quite nice. In the future, maybe we'll have vehicle combat as well, and we'll have to do the same here. So, yeah, quite satisfying. Okay, let's convert this into logic. So, I gotta be careful not to rely on cheap copy and paste too much, because that's how you make dumb mistakes. I really should just be coding every section from scratch. Okay, so let's do this. If shot, we grab these coordinates, the absolute coordinates, we grab the angle that are based on relative coordinates, then we grab the absolute coordinates, we pretty much copy this logic, and we won't be drawing anything here. Okay, that looks about right. Let's try again. So I can't shoot them through a wall. And now I shoot them. Okay, let's just clean it up. That was a little slower than expected. I guess I'm a little slow today. But that's fine, because that's pretty much what I want. So let's run through this one more time. Right. Of course, in the future we can adjust where the bullet actually exits. Pretty trivial. So then hit, hit, hit. Make sure order is arbitrary. Hit, hit, and so on. Okay, so I took the time to clean up some things, remove any comments or old sections, fixed up a few tiny bugs here and there. And so let's take a quick overview of what we have and how everything works as is. So we have our basic library loading, our firearm logic, our vehicle logic. Then we have our vehicles all nicely defined with their acceleration and max velocity. Then we have all our enemies. This is going to be where we handle player and enemy movement. Here is our vehicle logic, movement, which is identical to how it was in the original. Then we have some vehicle movement, which we managed to refine nicely. And now it's working to my expectations. Then here is our firearm logic. All of that. Then we draw game over condition and our map. So let's run through this, have a little fun, see how things are working out. So as our CR gun works as it should, we can kill people, hop in the helicopter, fly around, and I've tested this and it's quite thorough as far as I can tell. And it's really nice how I'm able to really go deep and create my own physics and dynamics while still keeping all the platforming and logic true to the original. And that's what you really want out of a library or a game engine. You want it to do some work, allow you to do more work, and not force you into a very particular framework that limits you to only a particular subset of games. And at the same time, you don't want it to just simply encase one line trivialities like velocity into some vanity named subroutine. So that's why this has been quite a bit of fun and quite a smooth development process. So now that we have our boilerplate firearm, let's make it work just as it would in the real game. So what I'm gonna have to do now is notice how when I shoot the enemy I have to let go of the mouse for the hit to activate, which is of course useful for debugging but not for gameplay. So let's quickly handle that. So what's gonna happen is presumably there's some kind of a frame rate going on. Time, introduce a variable, call it, I don't know, 10 frames. So every time the mouse is clicked, I need to say gun controls, and this will be set to 0. So every time the mouse is clicked, we start frame rate counter, shot time at 10, and we only allow shooting if this timer is reset to 0. And then during the redraw part we will decrement it every frame. Therefore you can only shoot once every 10 frames, and let's see how this works out. If and there we see if I hold the mouse, it's acting like something of a machine gun. So in addition to that, let's just, okay, if shot and shot time is greater than 0, okay, let's think. If shot, wait, I was looking at the wrong place. Okay, if shot calculate the hit. Okay, and then we can remove this part. There we go. So there's our gameplay logic, such that you can only fire a bullet every 10 frames, which as is gives us machine gun effect. Otherwise, it still acts as a one-shot. And as you can imagine, once we start adding more guns, this mechanism is going to come quite in handy. Let's try this. And this should be one. Okay, that works. So again, if I just hold it, I get a 50 frame cooldown period. And if I just press real quick, they die immediately, or it fires immediately. So once again, holding, and again. So that's nice. Another thing we can do is we can introduce some recoil. One thing I was thinking is maybe add a very small random angle to the gun trajectory to make the shots a little more random and make it more difficult to aim the further you are, so that you don't just click on the enemies with your mouse. You have to actually get close and all that, as well as recoil. So let me see if I can very quickly one-line some kind of a recoil. So if shot and the hit is registered, shouldn't all we have to do is the following? Minus 10 times cos of A. So what would happen? Like this. Huh. Okay. Okay, there's our recoil. So if we shoot down, what happens if we make it even larger? So if we shoot down, we get a little jump. If we shoot up, nothing, because we have the ground. But if we like very carelessly shoot like this, we end up falling down. So this should add a little bit of game and dynamics, because what I'm anticipating is you see a bunch of enemies coming and you don't want to be able to just, you know, pick them off real easily like that. So here I am coming at all these enemies, or they're coming at me, and I try to shoot them all, you know, and a bit of recoil, you know, add some gameplay and dynamics. So far we have our gun mechanism pretty much true to gameplay, as well as recoil, all of that. We then have the logic already pre-baked for machine guns. Vehicles work. We can exit them in the air. And this special military helicopter is going to have a machine gun, and we already know how to implement it. So I suppose we can call it there. And in the next part, we're going to maybe look at adding more guns, weapons, and then player or enemy AI, enemy movement, enemy shooting. And after that, it basically gets very game devy and all about level design. So that's that.